Welcome back. This is video 2 of lesson 4.8. If you haven't watched video 1, you need to go back and watch it. Okay, now we're going to talk about the discriminant. The discriminant of the associated equation of ax squared plus bx plus c equals 0 is b squared minus 4ac. It's the radicand of the quadratic formula. If b squared minus 4ac is greater than 0, if it's positive, then there are two real solutions. If it equals 0, then there's one real solution. It's a double zero. If it's less than 0, then there are two imaginary solutions. So we're going to find the discriminant of the quadratic equation and give the number and type of solutions of the equation. So our first one we're going to look at is x squared minus 8x plus 17 equals 0. And then we've got a couple more we'll look at in just a minute. Okay, so we want our equation in ax squared plus bx plus c equals 0 form. And our discriminant is b squared minus 4ac. And then we're going to have a description of the solution or solutions. So for x squared minus 8x plus 17 equals 0, b squared minus 4ac is negative 8 squared minus 4 times 1 times 17. And so that is 64 minus 68, which gives us negative 4. So that is less than 0, so we have two imaginary solutions. For part B, we've got x squared minus 8x plus 16 equals 0. So our discriminant is going to be negative 8 quantity squared minus 4 times 1 times 16. So that's 64, because negative 8 times negative 8 is 64. Minus 64, because 4 times 16 is 64, and so we get 0. So we have one real solution, and so it's going to be a double zero. And for C, that should be C. We've got x squared minus 8x plus 15 equals 0, and so we've got negative 8 quantity squared, so 64 minus 4 times 1 times 15. 64 minus 60 is 4. And so we've got two real solutions. So the discriminant helps us determine what types of solutions we'll have. Okay, as promised, we're going to talk about launched objects versus dropped objects. You learned previously that the height h in feet of an object t seconds after it is dropped is h equals negative 16t squared plus h naught, where h naught is the original height of the object. When an object is launched or thrown, the height h in feet of an object t seconds after it is launched or thrown is h equals negative 16t squared plus v naught, that's initial velocity, times t, plus h naught. And the initial velocity there needs to be in feet per second. Okay. A juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial vertical velocity of 40 feet per second. The juggler catches the ball when it falls back to a height of 3 feet. How long is the ball in the air? Because the ball is thrown, we're going to use this model. It's not just dropped. Okay, if he held the ball up and just dropped it, then we could use the dropped object model. So we're going to use the model h equals negative 16t squared plus v naught t plus h naught. To find how long the ball is in the air, we're going to solve for t when h equals 3, because that is when the juggler catches the ball. The juggler catches the ball when it falls back to a height of 3 feet. So we're going to write the model. H equals negative 16t squared plus v naught t plus h naught. We're going to substitute 3 for h, 40 for v naught because that's the initial velocity, and 4 for h naught because that's the initial height, as described in the problem. So we get 3 equals negative 16t squared plus 40t plus 4. So we're going to subtract 3 over to get it in standard form, and so we get 0 equals negative 16t squared plus 40t plus 1. Okay, we're going to use our quadratic formula with a being negative 16, b equaling 40, and c equaling 1. So we get t equals negative 40 plus or minus the square root of 40 squared minus 4 times negative 16 times 1 over 2 times negative 16. So we're going to simplify, and we're going to get 40 squared is 1600. And then 4 times negative 16 is negative 64 times 1 is still negative 64. So we have 1600 plus 64. So that's going to be 1664. And this is going to be one where we actually want to go ahead and use a calculator because we want to get a good feel for what the time is. So when we do negative 40 minus the square root of 1,664 divided by negative 32, we get 2.5. And when we do negative 40 plus the square root of 1,664 divided by negative 32, we get negative 0.025. So we have to reject the negative one because we can't go back in time. Okay, so we're going to reject the solution negative 0.025 because the ball's time in the air cannot be negative. So the ball is in the air for about 2.5 seconds. Okay, guys, thank you for taking good notes and listening to your lesson. Thank you to Larson and to Hope McDougall for the use of their book and their wonderful resources, including the website where I get most of the slides. Make sure you do the problems to try on your own, and we will go over them in class and then get you started on your rounds. Have a good day.